Good morning. Today I will discuss about inductance. What is inductance? Before discussing inductance, I think we have discussed all about power. Active power, reactive power, and behavior of reactive power with respect to inductance and capacitance. Because inductance and capacitance are totally depend on reactive power. Then, first, you know that power has two components. First is active power and second is reactive power. Power is known as apparent power, which is known as apparent power. Here, apparent power is written by V into I. Now, this apparent power can be divided in two parts. First is active power and second is reactive power. Now, active power is defined as V into I into cos phi, and reactive power is defined as V into I into sin phi. Now, what is phi? Actually, if you consider an element resistor and we supply it by a battery source, DC battery source V, then this is V and this is R, and the current will flow in this will be I. Then in this case, if you draw the phasor diagram of this circuit, then this will be V and this will be I. It means voltage and current in this case are in same line. And what is phi? Actually, phi is the angle between this voltage and current. Okay. Now if you consider this circuit is not purely inductive, but it's have impedance Z. It has impedance Z and energized by a battery source V. Then current will flow in this circuit I, and assume this load is inductive. This Z is inductive. If this is inductive, then if you draw the phasor diagram of this circuit, then this will be V and current will be like that. This is I, and this angle will be phi. This angle will be phi. This case is known as lagging case. Lagging, and this phi is give a cos phi, which is known as lagging power factor. Known as lagging power factor. Now, if you consider this load is capacitive, and also excited by a DC battery source, then this is V and this is current I, then the phasor diagram of this circuit will be this V. Phasor diagram of this circuit will be this is V and this will be I and this will be phi. It means this phi is a angle between V and I, and this case will be leading case, and known this cos phi known as leading power factor. Known as leading power factor. This is power factor and this one is also power factor. Now if we come about active power, if we come to know about active power, then as we have defined that active power is the V into I into cos phi. P of active is V into I into cos phi. Here V is the voltage across load and I is the current flowing in load. And you know phi is the angle between V and I. This power is also known as 2 power. Power also known as 2 power. Now, what is this 2 power? As it indicate by name, 2 power is something real. Also it is known as real power. Something real, also known as real power. Now, we want to discuss how it's real power and how it's 2 power. Actually, whenever there is losses in resistance somewhere, then this loss is indicate active power or 2 power or real power, and that loss will be in resistance. For example, if you consider heater, then in heater loss will be I square R, and this R will be, this I square R loss will be active power, or we can say 2 power or real power, you can say. But if you consider a capacitor or a inductor, this is a capacitor or this is a inductor, and this excited by not DC supply, assume this is excited by an AC supply, then what will happen? AC supply is this. Then behavior of capacitor is that it will be charged in first half cycle, and it will be charged in first half cycle in one direction, and it will be charged in second half cycle in other direction. As you can see, it will be charged in one direction and in one half cycle, and it will be discharged in second half cycle. Similarly, inductor also charged in one half cycle and it will be discharged in second half cycle. Now, these both element, inductor and capacitor, is a storing device. Capacitor store energy in the form of electrostatic and inductor store energy in the form of electromagnetic energy. It stores energy in the form of electromagnetic energy. It means you can say that there is no loss in the inductor and capacitor. There is no loss in inductor and capacitor. If there is no loss in inductor and capacitor, then what is its use? Question arises, if there is no loss in inductor and capacitor, then what is its use? Actually, whatever power is stored in energy is known as reactive power. Is known as reactive power or imaginary power. How it's imaginary? Because it's not visible, it's not realized, it's only in hypothetical way. Only we can assume, because no significant power is there. We can only assume that something is going on, because whenever a capacitor or inductor supplied by a source, then it will be charged and again discharged. Whatever it will take, it will deliver again same amount.